All right, so in my attempt to create a whiteboard I can put on the table and draw on, I have this sheet of foam board. So we're going to draw some batteries here. And my dot cam unfortunately can't go really high enough to see the big picture, so I'm going to kind of draw it out and then hold it up to the camera here. And there you go. I'll try to draw it on the dot cam. We'll see how we do. Okay, so let's draw our 3-cell battery here. So we're just going to draw kind of a rectangle to start out with. There we go. We're just going to divide that into 3 compartments. Okay. So we'll say it's cell number 1, number 2, and number 3. Okay. And so let me make this a little bit bigger here. Make it a little bit easier to see perhaps. Okay. So we have cell number 1, 2, 3. We're going to kind of just imagine the lines up here going out to our connector. A little bit off screen. There we go. Okay, here's our connector, our XT60. That's this yellow guy right here. Okay. That's our main connector or main discharge lead. Okay. And then we have our individual, I'm not going to draw this accurately, but we'll draw 1, 2, 3, and then we have our ground, and we have our balance lead right here. Okay, I'll show you guys some diagrams of that more in a second, but this is our balance connector. Okay, balance connector. There we go. All right, so like I mentioned, we have the voltage here, the 11.1 of the battery. So that's our nominal voltage. So that voltage is going to be kind of where the battery is usually shipped at. But like I said, people will tend to store batteries a little bit higher. So I'm going to put some numbers here for a second. All right, so we may be able to see some of those numbers. Let's see. It looks okay. I'm going to try to hold it up, see if this will work better. I don't know if this will work better for the camera or not. Well, it's not because it's too tall, actually. That's not going to help. All right, let me tilt the camera back here for a second. And we'll just bring this in as best we can. Okay, there we go. That's not too bad. Okay, so as we look at a three cell battery, you often hear the term 3S, right? So we'll write that over here. 3S, right? Like, how does that make any sense? Three out of these cells, cells doesn't start with S, right? It is a 3-cell battery, okay, but 3S is commonly used to differentiate what type of battery it is. So what that means, basically, what it's saying is that in the world of electronics, you can wire things in parallel or in series, okay? I'll show you some pictures of this in the slides here in a minute, but basically, if the cells are wired in series, we take the voltage and we add it together to get the total voltage. Okay, if you take 3.7, you go 3.7 plus 3.7 plus 3.7, or 3.7 times 3 equals 11.1. So these cells are wired in series, which means we add the voltages together to get the total voltage of the battery. Okay. If they're wired in parallel, what we do is we'd actually add the capacity. We haven't talked about capacity yet, so don't worry about that. But if they're wired in series, then we add the voltages of each cell, 1, 2, 3, to get the total voltage, and the S is for series. Okay. So what it's really telling you is not only that there's 3 cells, right, but that there's 3 cells wired in series, okay, as opposed to parallel. Hopefully that makes sense. Okay, so as we look at our other numbers here, right, I told you guys that batteries like to be kind of a happy place, medium spot as far as charge goes. If you keep them fully charged for a long time or fully discharged for a long time, they'll be unhappy that the batteries will be damaged over time. You might say, well, that isn't 0 volts, Duke, that's 3 volts, and that's correct. So you do not want to take a normal lithium polymer battery below 3.0 volts per cell. That's the absolute bottom. So you really want to probably not discharge more than down to 3.25 or 3.3 or even 3.4, depending on your personal preference. That could be your lower limit there. But never take it below 3.0 volts per cell or else you'll damage the battery. Like, it might still work after you're done, but it won't have the same performance as it once did. So our range is from 3.0 at the absolute minimum, we'll say 3.3 maybe as a safeguard, to 4.2 volts for a lithium polymer battery. And so when we charge the battery up on the charger, we get it up to 4.2. When we fly it, we discharge the battery down to wherever it is we fly it till, and then we charge it back up again, right? And batteries are typically good for a number of cycles, depending on the quality of the battery. Could be hundreds or could even be maybe thousands. I'm not sure actually on that. But there's a lifetime for the battery. But when you're storing the battery, if you store it at that nice storage voltage, I like to put mine about 3.85 volts. If you store them at that voltage, you can leave them on the shelf for a long time without a lot of damage to the battery. So they can just sit for a while. If you're going to go fly and then it starts raining, and your batteries are all charged because you're going to go fly, and it starts raining, then you get other things to get busy. If it's been a week or two, you really want to put those batteries back to storage voltage. Don't let them sit longer than a couple weeks at fully charged voltage. At a max. That's what our textbook author recommends. I think that's good advice to not go longer than that as far as fully charged or fully discharged voltages. Okay, so that hopefully helps explain a little bit of this 3-cell 11.1. You're probably going to see that now. 3-cell 11.1 marking here on the battery. Okay, so that's what that has to do with the voltage of the battery and how many cells it has. Okay, so different aircraft will use different numbers of cells on their batteries. You may buy an aircraft and it may already have batteries that come with it, or it may say, hey, this aircraft is meant to be flown with 3-cell batteries or 4-cell batteries or 6-cell batteries. And that'll be based on the other hardware components on the aircraft, but just make sure you get the battery that has the right count of cells, because the voltage, if voltage is too high for what you're plugging it into, then you can damage things pretty easily. And then you have to buy a new aircraft or whatever it was you plugged it into. Okay, so there's our voltage, a little voltage discussion there for a second. Okay, let's go ahead and switch over for a second to this capacity discussion. So I'm going to rotate my whiteboard around here. It'll give us a fresh slate. Okay, so bring that up a little bit. And we'll get some focus on there. There we go. Okay, so we have another number here. This is 1400 milliamp hours. Okay, actually I'm going to break the video right here. That's a good breaking point, sorry.